Hello. So in this video, I'm going to do a demonstration of the self-driving car that I built with Carla and Python. So first off, I'm going to do a demonstration, a description, a high-level description of how the code works. And then after that, I'm going to show the car in motion. So yeah, so I'll be just going quickly through the code. I won't explain every little detail. So first off, I create the simulation. This That's what this line of code is doing. The world I load town 5, which is one of the maps loaded into Color. So yeah, Color is a simulator for self-driving cars. It comes with a set of maps. I think about 8 maps that are already loaded. So I just load one of those maps. That's this. That's the simulation, and then I load the blueprint library. The blueprint library contains the set of characteristics that our characters will have. For example, the different vehicles, the pedestrians, the traffic lights, and so forth. And then after that, I create the blueprint for the vehicle that I want to add into the simulator. In this case, I chose the Model 3, which is a Tesla. And then I also create the spawn point, which is the exact position that I want my car to be spawned on in this simulation. And then to create the vehicle, I code the world.spawn actor method, and then pass in the vehicle blueprint and spawn point. So what this does is that it creates the vehicle, and then it spawns it at the spawn point that is specified before. And then after that, I'm going to add the vehicle to the actor list. What this allows me to do is that I will be able to destroy the vehicle after running the simulation, in order to avoid collisions with other characters in case I want to run the simulation for the second time. And then after that, I attach a camera to the vehicle. That's what this line of code is doing. And I also add the camera to the actual list. And then after that, I add the spectator. The spectator allows us to follow the vehicle around the town when it's moving. And after that, I set the location of the spectator to the location of the car. So it will just be following the car around. And then, so our vehicle doesn't have any controls. So if we run this code without any controls, the vehicle will just remain stationary. So in order to add controls to this vehicle, what we do is we call the run step method. This one, it's a different class which provides control to our vehicle. So we apply the control from this class. So I just set the simulation to run for 180 seconds. That's how long the demonstration will be. And then finally, after we've finished running the simulation, we're going to destroy all actors just in case we want to run the simulation again for the second time. Because if we do not destroy the actors and we try to run the simulation for the second time, there will be collisions. So we don't want that to happen. So the most important part of the code is this one, which generates the control that will pass to our vehicle. So I'm going to explain that part of the code. It's in this file. Right. So the run step method, what it basically does is that it checks the environment in order to determine what kind of control to return or to apply to the vehicle. The the control consists of the throttle, uh, the brake, and the speed of the vehicle. So depending on the environment, this method sets the control to whatever value it determines. So yeah, this first line 260, what it does is that it checks the tailgate counter, and then if the tailgate counter is greater than 0, it decrements the tailgate counter. That means our car is following other cars, like the distance between our car and the other cars, or the car in front of us, it's it's less than the distance that we want it to be less than, or it's less than the minimum distance allowed. So if that happens, we decrement the counter, and then we also get the location information, and this returns this line of code, line 264. It returns the coordinates of the vehicle. So after we get the coordinates of the vehicle, it allows us to like check the the states of the lights, and also to check for pedestrians around. So line 267, we check if we are at an intersection, we check the state of the light, whether the light is red or the light is green. And if the light is red, that means we apply the self-taught emergence stop method. What this does is that it brings the vehicle to an emergence stop. And same applies if there is a vehicle, I mean, if there is a pedestrian in front of us, and if that pedestrian is close enough to the self-driving car will come to an emergence out. And if there is also a vehicle obstacle in front of us, that means other self-driving cars or non self-driving cars. And if there's other obstacles in front of us, we also come to an emergence stop. Else, we just continue moving the way we were moving. And if we're at an intersection, we apply the intersection behavior. The intersection behavior basically it checks their surroundings, also to like determine what kind of behavior should be returned to the vehicle. Else, if all those conditions didn't apply, we will just continue with the normal behavior. That means if the car was like traveling in a straight line, it will just continue traveling in a straight line. And then eventually we set the control to the local planner, the run step. What this line of code does is that it also the local planner is information about the whole town, so it allows us to generate the next waypoint where the car is supposed to move to, because the car just makes random choices whether to turn right or left. So that's what this line of code does. And then eventually we return the control, and then we get back to our main file here. So we return the control. So that's the control that the vehicle will be using in order to navigate throughout the town. So I'm going to run this code, and you'll be able to see how it works. Let me see. Let me make this. So at a red traffic light, it stops, and then it will continue its motion when the light turns green. Just make sure this is in full screen. So we are able to follow the car around the city because of the spectator that we added. So if we forget to like update the spectator view, the car will continue with its motion, but we won't be able to see it. Okay, and it stops at a red light and then continues its motion. Chooses to turn left. So as of now, there are no other vehicles in the simulation. I just wanted to test whether the car follows all the traffic rules before I added other self-driving vehicles. So yeah, the plan is to add other self-driving vehicles and set their control to autopilot and see how this car interacts with those other vehicles. So yeah, it's back where it started. So it has completed a full circle, and yeah, that's all about the demo. So it's gonna continue running um, for 180 seconds because that's what we set as the limit. And then after that, we're gonna destroy all the actors. I'm just gonna terminate it. Okay, I think it's almost time up anyway. Right. So time up. We destroyed all the actors. So that's all that I wanted to show about this self-driving car. See you in the next video.